Play the Moola Mantra.
Om Satye Parasaktiye Om Satye Adhiparasaktiye Om Satye Maruvurarasiye Om Satye Om Vinayaka Om Satye Om Kamachiye Om Satye Om Bangaru Kamachiye.
Today we are delighted to have with us our distinguished alumna, Mrs. D. Devi, a proud 2005 batch graduate of the IT department. She has made remarkable strides in the field of education and is currently serving as an assistant professor in the Department of CSE, School of Computing, Sathyabama University. With a wealth of experience in academia and expertise in programming, she has been instrumental in shaping young minds in the field of computing. Her session today on compiler basics will provide us with valuable insights into one of the core aspects of programming, understanding how code is translated into machine language. Ma'am, we take immense pride in your accomplishments and we sincerely appreciate your time and effort in joining us today. Compilers are the backbone of software development, and your expertise will surely enhance our understanding of this fundamental topic. Without further delay, let's dive into this insightful session. Once again, a warm welcome to all, and I hope this webinar proves to be an enriching experience for everyone. Ma'am, the session is now yours.
Thank you, Anushya, ma'am. Ma'am, is it audible, ma'am?
Yes, yes. It is audible, Devi. You can continue.
Thank you so much, ma'am. Good evening, everyone. It's my immense pleasure to be here with you today. First of all, I am Devi. I have completed my UG at Adhiparasakthi Engineering College in the year 2006. I am proudly say I am the alumni of the Adhiparasakthi Engineering College. It is truly excited to have the opportunity to convey my speech with all of you. First of all, I would like thank Dr. Bhuneshwari ma'am, who gave the opportunity to give the speech in front of you. Thank you, ma'am. So I am working as the assistant professor, Sathyabama Institute of Science and Technology in the Department of Computer Science. So I'm welcoming all for today's session. Today I'm going to talk about the basics of compiler design. Ma'am, my screen is visible, ma'am.
Yes, ma'am. It is visible. Screen is visible. You can continue.
Thank you. Thank you. Thank you. Is it in slide share mode, ma'am?
Yes, ma'am. Yes, it is in the sharing mode only.
Thank you.
Yeah.
Thank you, ma'am. Thank you, ma'am.
Screen is visible to all. Students, for all of you, is it visible?
Yes, ma'am.
Yes, ma'am.
Before entering first we know about what do you mean by what is compiler. MOL. Ma'am, screen move ஆகுதா ma'am?
No, ma, it is not moving. You
Yes.
give the slideshow. You give the slideshow option. From beginning. That from beginning. Screen is visible.
But it's not moving, ma'am.
Oh, it's not going to the next slide. Huh? Yes, we can
Yes,
see.
ma'am, it's not going.
No, if you give that slide, so from beginning is there. Now, if you click that, I think left corner,
From
top left, from beginning. We are able to see your screen, ma. If you move your cursor,
next
your
screen is not next slide is not moving, ma'am.
not moving to the next slide.
Yes. Ma'am, shall I send the screen to you? Just you can try, ma'am.
Okay, yes, yes. Send it to me. Send it to me.
Because it's not moving. I don't know why, ma'am.
Okay, send the PPT to me. I'll share it.
Yes, ma'am. Yes, ma'am.
Hemakumar, are you there? Is student stay back? Share it once he sends the PPT, okay?
Ma'am, you wait, ma'am.
Now is it visible? Is it visible? I think it is like a PDF. Students, is it visible?
Yes, ma'am.
Is it visible or not?
Yes, ma'am.
Okay, okay. So when I'm moving it,
Ma'am.
Yes, ma'am.
You just scroll that PPT, ma'am.
Yes, basics
Yes.
of. Okay, now is it visible?
Yes. Yes, ma'am. Yes, ma'am.
Okay, fine. You go with it. I'll take her. You go
Yes.
with it.
Okay, ma'am. Okay, sorry for interruption, students. We'll discuss about basics of compiler. First, we know what is compiler. So, compiler is a programming language. It is used to translate one form of the program into another form of the program. So, one form of the program is nothing but say here high level language. The another form is nothing but low level language. So, high level language, in any language you can take example C, C++, Java, Python, any language. The low level language is nothing but assembly language called mnemonics codes. During compilation process, we'll get some errors. These errors will be returned to the users with the help of compiler. So next we'll discuss about language translator. With the help of language translator only, we are converting one form into another form. We'll have three different types of translator. One is assembly, next interpreter, third one is compiler. Next slide, ma'am. So
Yes.
we'll take this example. So this is one of the high level language. The code is written by C language. This code sent to the language translator. Finally, the language translator is converted into high level language code into machine code. Machine code is nothing but ASCII values, zeros and ones format. ASCII is nothing but American Standard Code for Information and Interchange. With the help of language translator only, we are going to convert one form into another form. First, we'll discuss assembler. So assembler is nothing but mnemonics code. So this code sent to the assembler. This assembler is converted into machine code. Next, we'll talk about interpreter. Interpreter is nothing but it's checking of line by line. The example of interpreter language C++, Java, Python. So interpreter also reads the source code. Source code is nothing but high level language. These high level language converted into final machine level language. So this is the internal architecture of language translator. First preprocessor, next phase is compiler, third assembler, and the last one is loader and linker. The preprocessor is nothing but, move on to next slide, ma'am. So take this example. This is the high level language. The code is written in the C language. So the first include studio.h is the pre-processing stage. This, with the help of pre-processing stage, the include is removed. Studio.h is nothing but header file. With the help of header file only, we can able to print our output. The pre-processor divided into header file and then main program. So we can able to see that output pure language is nothing but the dividing of header file and main program. So compiler is the another phase of language translator. Already I thought what is compiler? Compiler is a software language used to convert one form of the program into another form of the program. So compiler reads the pure high level language. Pure high level language is nothing but here pre-processing part is separated, the header file is separated. We can able to see only main part of the program. So that program reads the compiler. and the compiler converted that pure level language program into assembly language program. Assembly language is nothing but our mnemonics code. So move, load, store, these are all the example of assembly language. Assembler, it states the assembly language and converted into relocatable machine code. Relocatable machine code is a combination of zeros and ones. It is also called as ASCII code. The relocatable machine code is the code can be loaded anywhere in the memory. That is called relocatable machine code. It is also one of the ASCII code only is a combination of zeros and ones. So the final part of the language translator is loader and linker. The relocatable machine code feed into loader and linker. So loader and linker, with the help of loader and linker, the machine code is loaded into RAM and ready for the final execution. So this is the last phase. With the help of this phase, we get our absolute machine code. So absolute machine code also combination of zeros and ones. So this is the final output of language pre-processing. First, our source code. The source code is converted into pure high-level language. The high-level language is feed into compiler. Compiler converted into source code into machine code. That machine code, the assembler is used to convert the assembly language into machine code. Loader and linker. The loader and linker is used to load the data into RAM and ready for the final execution. So this is the final output of language pre-processing system. So now discuss about phases of compiler. The compile has 6 different phases. The first one is lexical analyzer, next is syntax, third one is semantic analyzer, next intermediate code generator, code optimizer. The last phase is target code generator. The lexical analyzer is the first phase of the compiler. The lexical analyzer only reads the source code and target generator generates the final output of the compiler. The symbol table and error handler is the another different part. The symbol table it is nothing but a data structure. It is used to store the all the details about the phases of the compiler, and the error handler is used to handling the errors during the compilation process. So the phases of compiler divided into 2 phases. One is analysis phase, another one is synthesis phase. The lexical analysis, syntax analysis, semantic analysis. These 3 phases are called analysis phase. Then intermediate code optimization and target code. These 3 phases are called synthesis phase. One more thing, lexical analysis, syntax, semantic, intermediate code. These 4 phases are called front end of the compiler, and code optimization and target code called back end of the compiler. We'll discuss each phase operation one by one. Next, ma'am. So first phase, lexical analyzer. Lexical analyzer is the first phase of the compiler. It reads the source program. Source program is called our high-level language program. In any language, C++, Java, any language we can take it. It reads the line-by-line code. And the final output of the lexical analyzer is the tokens. Token is nothing but stream of character. So we have different types of tokens. One is identifier, operator, constant, keyword, literal, punctuations, special characters. These are the few examples of tokens. Identifier is nothing but any variable, A, B, C, D, any variable, printf, scanf, anything is called identifier. Operators, any operators, addition, subtraction, multiplication, division, any operators we can take it. Constant is nothing but values 3, 4, 5, etc. Keyword is nothing but int, float. These are keywords. Literals is nothing but any printf, scanf statements are called literals. Punctuations nothing but comma, semicolon. These are punctuations. Special character, at, hash, dollar. These are special characters. So this is simple example of tokenization. Take this that example. Int main is a simple C programming language. Int main open and close parenthesis, starting brace, curly brace, int x, a equal to 2, b equal to 3, c equal to 5, semicolon, x equal to a plus b star c, semicolon, printf, the value of x is percentage d, comma x, return 0, comma, return 0, semicolon, close brace. This is simple C program. So this C program reads the token, then final tokenizer output is this here considered as a keyword. So already I told you, lexical analyzer used to read the stream of tokens and stream of character and converted into tokens. These tokens are called any keyword, identifier, punctuation, operator, constant, literals, or special characters called as token. Take this example, int and return. These are keywords. Then identifier called main, comma, x, a, b, c, printf. Already I taught you identifier is nothing but any variable, main, printf, scanf. These are called identifier. Punctuation is nothing but open and close brace, open, comma, semicolon, close brace. These are called punctuations. Operators nothing but equal, plus, star. These are operators. Then constants is called values. 2, 3, 5, 0. These are constants. Literals is printf, scanf statements. The value of x is percentage d, that is called literals. This is the example of token. So first phase, lexical analyzer. Lexical analyzer reads the stream of token and lexical analyzer reads the stream of character and converted into tokens. This is the operation of lexical analyzer. Next phase is syntax analyzer. Syntax analyzer is called parser analyzer. So parser analyzer is used to generate the parse tree. It's format a tree structure that is called parser tree. So syntax analyzer reads the output of the phase 1. Phase 1 is lexical analyzer. So output of lexical analyzer is stream of tokens. These tokens read by syntax analyzer and generate the parse tree. Take this code, x equal to a plus b star c. So parser tree depends upon the context-free grammar. With the help of context-free grammar only, we are going to generate the parse tree. So here we have the context-free production. S tends to id equal to e, semicolon. E tends to e plus t or t. T tends to f star f or f. F tends to id. This is called context-free grammar. With the help of this grammar only, we are going to construct the parse tree. Here S is nothing but starting symbol. E is expression. T is term. F is factor. The expression, ma'am, previous slide, ma'am. Syntax analyzer. The expression E is assigned to identifier. So take the first statement, S tends to ID equal to E, semicolon. E is expression, equality is the assignment operator. So the expression E is assigned to identifier followed by delimiter. Delimiter is nothing but semicolon. Okay. So x equal to a plus b star c, semicolon. So here x, a, b, c. These are called identifier. ID equal to ID plus ID star ID, semicolon. So S is the starting symbol. So next S equal to ID equal to E, semicolon. So S ID equal E, semicolon. So the expression E may be expression plus term or term. So E is divided into E plus T. So next expression is considered as a term also. In left hand side, expression is considered as a term. So next, T tends to T star F or F. The T considered as a T star F or F. So T is divided into T star F. Next, T considered as a F also. T tends to F. Then F tends to ID, factor tends to ID. So this tree is created by top to bottom and right to left. So here equal, semicolon, plus star ID. These are considered as terminal symbols. So capital S, capital E, capital T, capital F. These variables are considered as a non-terminal symbol. So with the help of context-free grammar, we constructed as a parse tree that is called as syntax tree. Next, semantic analyzer. So semantic analyzer reads the output of the syntax tree. With the help of semantic analyzer, the tree is verified semantically or not. It means that the syntax tree follows the rules and regulation of the context-free grammar. Our previous tree followed context-free grammar. There is no error in that semantic tree. So with the help of semantic tree, we'll check our parse tree is followed by context-free grammar or not. So next phase, intermediate code generator. Intermediate code generator used to generate the three address code. Intermediate code generator reads the semantic output. Then that output is fed into intermediate code generator. So ID equal to ID plus ID star ID semicolon is derived from this equation x equal to a plus b star c. So intermediate code generator is used to generate the three address code. So first we'll take this equation x equal to a plus b star c. This equation is evaluated by left to right. So first will execute b star c. B star c stored into temporary variable t naught. Next we are going to add a plus b. So first we are going to evaluate this equation left to right. First we evaluate the expression b star c, because b star is having highest precedence. So first we need to evaluate the b star c. So b star c stored into t naught temporary variable. Next, a value will be added into b star c. So a plus t naught. So a plus t naught will be stored into temporary variable t1. The final output will be stored into x. So x equal to t1. So three address variable is nothing but three variable, two operands, that is called three address code. Is very important part of the compiler. Next phase is code optimizer. Code optimizer gives the optimized code. It's nothing but three address code, generate the three address code. With the help of code optimizer, we can able to avoid the redundancy of the code. So consider this three address code: t naught equal to b star c, then t1 equal to a plus t naught, x equal to t1. This is our intermediate code output. With the help of code optimizer, we can reduce the number of lines, 3 lines into 2 lines. We'll get the same output without any changes. So t naught equal to b star c, then x value equal to a plus t naught. So code optimizer is used to reduce the number of code. It means that we can able to avoid the redundancy of the code. Next, our final stage is target code. Target code is used to generate the mnemonics code is the last stage of our compiler. So optimized code is nothing but will reduce the number of codes, that is called optimized code. This optimized code is feed into target generator. This target generator generate the our final output. Final output is in the form of assembly language. Consider this output. See this output: move EAX, D word PTR RPB minus 8. EAX is nothing but accumulator registered. D word PTR is called data word pointer. RPB is reference base pointer minus 8. First, T not equal to B star C. That value stored into so T not equal to B star C. So the C value stored into EAX register. EAX is called accumulator register. The C value stored into accumulator register. Next process, B is multiplied with C. So next, I mul EAX comma D word PTR RPB minus 12. So B RPB is nothing but reference base pointer is the minus 12. So RPB minus 12 is nothing but B. That B value is multiplied into C. Again, that B into C stored into EAX register. Next, move EDX comma EAX. Now EAX having the value of B star C. That B star C value stored into EDX. EDX is the another register. It is a 32-bit register. Next, D word PTR RPB minus 4. RPB minus 4. Minimize the screen, ma'am. It's okay, ma'am. EX D word PTR RPB minus 4. RPB minus 4 is stored in the A value. That value stored into EAX. Next, EDX holds the B star C, then EX holds the A. That both values are added and finally stored into X variable. How this is the way assembly language will work. So phases of compiler: first phase lexical analyzer, next phase syntax analyzer, third phase semantic analyzer, fourth phase intermediate code generator, next phase code optimizer, the last stage is target code generation. First phase lexical analyzer. Lexical analyzer is the first phase of the compiler. It reads the stream of character and the final output of lexical analyzer is token. Token is it may be identifier or keyword or literal or punctuation or special character, anything. Next phase is syntax analyzer. Syntax analyzer used to generate the syntax tree with the help of lexical analyzer. Syntax analyzer reads the output of the lexical analyzer. That with the help of that output, the syntax analyzer generate the syntax tree. One more thing, syntax analyzer follows the context-free grammar. With the help of context-free grammar only, syntax analyzer generate the syntax tree. Third phase is semantic analyzer. The main aim of semantic analyzer, it checks the syntax tree, follows the rules and regulation of the context-free grammar. Next one is intermediate code generator. Intermediate code generator used to generate the 3 address code. 3 address code is nothing but three operand, 2 operator, that is called intermediate code generator. Next one is code optimizer. Code optimizer is used to reduce the number of codes, that is it eliminate the code redundancy. Then target code, this is the final stage of phases of compiler. It generate the final output, that is called assembly language. Next, tools of the compiler. In lexical analyzer, with the help of lex tool, we are going to generate the lexical analyzer. Then syntax analyzer, with the help of York tool, we are going to generate the parse tree. York is nothing but yet another compiler. This tool used to generate the syntax analyzer. Then lex tool is used to generate the lexical analyzer. Then lexical analyzer, syntax, semantic, intermediate code generator. These four phases are called front end of the compiler, and the code optimizer, target code. These two phases are called back end of the compiler. Yes, ma'am. This is the Lance tool. If you want to know about more knowledge about compiler platform, you just read this book. You will get more knowledge. Thank you, ma'am. Students, if you have any doubts, any queries, you can ask me.
Yes. If you have any doubts, you can ask now. Did you because this is very new to the students actually.
Okay, ma'am.
IT, we don't have
Ma'am,
compiler, but now we are having TOC actually.
yes, ma'am. It's a gate syllabus also, ma'am, compiler.
Okay, fine. Yes, students, you have any doubt? No doubts. Okay. Is it all clear or what? Okay, ma'am. Thanks a lot, Devi. Shall we come to the conclusion? Devi?
Om, Om Shakti. As we reach the end of this insightful webinar, it is my privilege to extend a heartfelt vote of thanks. On behalf of our institution, I sincerely express my gratitude to our esteemed speaker, Mrs. Devi, for taking the time to share her expertise on compiler basics. Your valuable insights have given us a deeper understanding of this fundamental topic, and we truly appreciate the effort you put into making the session both informative and engaging. A special thanks to our respected HOD, Dr. A. Boneshwari ma'am, for her constant support and guidance in making such knowledge sharing session possible. I would also like to extend my appreciation to all faculty members and the participants for your enthusiastic presence and active participation. Your engagement added great value to this session. Let us now conclude with Vartu.
Thanks a lot, Devi.
Thank you.